Lesson 2. The Electromagnetic Spectrum. Reading Guide. Key Concepts. Essential Questions. What is the electromagnetic spectrum? How do electromagnetic waves differ? Vocabulary. Electromagnetic spectrum. Radio wave. Microwave. Infrared wave. Ultraviolet wave. X-ray. Gamma ray. Inquiry. How many colors? Can you name the colors of the rainbow? You might know the familiar colors from red to violet, but no one can name all the colors. Rainbows are a continuous range of colors. Each color is an electromagnetic wave with a slightly different wavelength. What are the various types of electromagnetic waves? What is the electromagnetic spectrum? The waves that carry voices to your cell phone, the waves of energy that toast your bread, and the X-rays that a dentist uses to check the health of your teeth are all electromagnetic waves. The changing motion of an electric charge produces each type of electromagnetic wave. Each type of wave has a different frequency and wavelength, and each carries a different amount of energy. Electromagnetic waves might vibrate from 1,000 times a second to trillions of times a second. They might be as large as a house or as small as an atom's nucleus. The electromagnetic spectrum is the entire range of electromagnetic waves with different frequencies and wavelengths. Key concept check. What is the electromagnetic spectrum, and how do electromagnetic waves differ? Classifying electromagnetic waves. There are many shades among the familiar colors of a rainbow. Each color gradually becomes another. However, the electromagnetic spectrum is organized into groups based on the wavelengths and frequencies of the waves. Like the colors of a rainbow, each group blends into the next. You will read about how electromagnetic waves are grouped on the next pages. Number 1. A radio wave is a low-frequency, low-energy electromagnetic wave that has a wavelength longer than about 30 centimeters. Some radio waves have wavelengths as long as a kilometer or more. Radio waves often are used for communication. The wavelengths are long enough to move around many objects, but the energy is low enough that they aren't harmful. On Earth, radio waves usually are produced by an electric charge moving in an antenna, but the sun and other objects in space also produce radio waves. Number 2. A microwave is a low-frequency, low-energy electromagnetic wave that has a wavelength between about 1 millimeter and 30 centimeters. Like radio waves, microwaves are used for communication, such as cell phone signals. With shorter wavelengths than radio waves, microwaves are less often scattered by particles in the air. Microwaves are useful for satellite communications because they can pass through Earth's upper atmosphere. Because of the frequency range of microwaves, food molecules such as water and sugar can absorb their energy. This makes microwaves useful for cooking. Number 3. An infrared wave is an electromagnetic wave that has a wavelength shorter than a microwave but longer than light. Vibrating molecules in any matter emit infrared waves. Even your body emits infrared radiation. You cannot see infrared waves, but if you warm your hands near a campfire, you can feel them. Your skin senses infrared waves with longer wavelengths as warmth. Infrared waves with shorter wavelengths do not feel warm. Your television remote control, for example, sends out these waves. Number 4. Light is electromagnetic waves that your eyes can see. You might describe light as red, orange, yellow, green, blue, indigo, and violet. Red light has the longest wavelength and the lowest frequency. Violet light has the shortest wavelength and the highest frequency. Each name represents a family of colors, each with a range of wavelengths. Number 5. An ultraviolet wave is an electromagnetic wave that has a slightly shorter wavelength and higher frequency than light and carries enough energy to cause chemical reactions. Earth's atmosphere prevents most of the sun's ultraviolet rays from reaching Earth. But did you know that you can get a sunburn on a cloudy day? This is because ultraviolet waves carry enough energy to move through clouds and to penetrate the skin. They can damage or kill cells, causing sunburn or even skin cancer. Number 6. An X-ray is a high-energy electromagnetic wave that has a slightly shorter wavelength and higher frequency than an ultraviolet wave. Have you ever had an X-ray taken to see if you had a broken bone? X-rays have enough energy to pass through skin and muscle, but the calcium in bone can stop them. Scientists learn about objects and events in space, such as black holes and star explosions, by studying the X-rays they emit. Number 7. A gamma ray is a high-energy electromagnetic wave with a shorter wavelength and higher frequency than all other types of electromagnetic waves. Gamma rays are produced when the nucleus of an atom breaks apart or changes. As shown in the photo, gamma rays have enough energy that physicians can use them to destroy cancerous cells. Like X-rays, gamma rays form in space during violent events, such as the explosion of stars.